Hi everyone, welcome to this video on compiler design discussing the principles of Peephole optimizations. Let us dive into the video. Whatever optimization techniques discussed earlier actually work well on the intermediate codes. Can we do something for the target code or the assembly code? Yes, there comes the concept of Peephole optimization. Peephole is a short sequence of instructions according to the traditional compiler design techniques, where the optimizer tries to replace the sequence of codes with another equivalent set of codes but faster. That is the need for going for this Peephole optimization. Intermediate code optimization helps us to minimize the number of assembly level codes in the target language, while the Peephole optimization tries to reduce the execution or space requirements of the target code so that the efficiency of the compiler is better. So the target code often contains redundant instructions and suboptimal constraints. So the target code is often of poor quality. We try to examine a short sequence of target instructions which we call Peephole and tries to replace by another shorter or faster sequence of instructions which help the target code optimized. So Peephole is a small moving window on the target systems. It is a window by window optimization procedure, and hence Peephole is said to be the shorter sequence so that optimization can be even better. The requirement is to the quality of the code should be improved, and what is the solution to it is applying the better optimizing transformations. So what is the demerit of the code generator? It might mislead in certain cases. The resulting code might involve more memory requirement or space requirement, and it might involve more running time also. What are the goals and objectives of Peephole optimization? The primary goals are improving the performance and reducing the code size. And what is the objective? To choose an effective technique. And how to achieve? These are the methods: redundant loads and stores, unreachable code elimination, algebraic simplification, use of machine IDMs. So how can we remove the redundant loads and stores? In the case of arithmetic expressions having written in the form of 3 address code, there is a need for moving the value to the register and from the register to the variable, that is register to memory, memory to register. Subsequently these two are happening alternatively, and subsequently move register to memory and memory to register, that is R0 comma A and A comma R0. It is unnecessary redundant instructions, so one of the instructions can be well removed where we wanted to store the actual data can be kept. It is actually in the register, and we move to memory, and from memory we again move to register for performing the operation, so we can better avoid the second instruction so that the code is optimized. And in the form of this one, uh, consider the following code which involves condition, an if condition, where the debug value is defined to be 0, and if condition is followed below where the debug is evaluates to 0 itself, and this if condition in the program will not be executed, and it is not necessary for us to include this if statement at all. It is unreachable, it will not be executed. If it is available in the program, it will be transformed into the following set of intermediate codes, and this will further be transformed into assembly code or machine code. Such unnecessary translations can be removed, and time and space requirements can also be removed. This is the meaning of unreachable code. In other terms, we can call these as dead codes as well. Unreachable code elimination is continued. Again, it is the same instruction. Again, checking whether debug is not equal to 1 or not is equal to 0. Checking again with the compared with the previous example, it is unnecessary jumps over jumps. So these kind of instructions can be well eliminated, uh, ensuring the better optimization. Constant propagation is the meaning of an expression having only the numerics and eliminating the computation on these numerics. So that is the meaning of constant propagation. Understand from the first line, if 0 is not equal to 1, go to L2. 0 not equal to 1 involves both are numerics, they are not operands involving a variable name, but they are directly the constants, so that the value of 0 not equal to 1 can be computed well in advance, so that this computation and computation overhead can be reduced. Converting this 0 not equal to 1 is actually the meaning of constant propagation. Finding out the value of 0 not equal to 1 is the actual constant propagation, which will avoid unnecessary intermediate code and unnecessary target code generation. Will avoid time and space requirements also. Flow of control optimizations is the next ideology. So there is a statement called go to L1 and which follows a sequence of statements in between, and when the control jumps to L1, it again asks the computer to jump to L2. Rather, it can directly tell the computer to go from L1 to L2. Why there is a intermediate jump? So these kind of jumps can also be eliminated. Direct jumps can be introduced. Algebraic simplifications is yet another optimization method in the Peephole optimization, where x equal to x plus 0 has no meaning and x equal to x star 1 has no meaning. They are merely the same value but represented in order to perform some computations. But these kind of simplifications can be carried out. These codes need not be transformed, these kind of statements need not be transformed into intermediate code or target code. They can be simply ignored. Another form of algebraic simplification is the strength reduction. For an example, expression involving power can be replaced by multiplication. An expression involving multiplication can be replaced by left shift. An operation involving division can be replaced by right shift operator. The meaning is that power operator is costlier than multiplication. Multiplication operator is costlier than left shift. Division operator is costlier than right shift. So that we try to replace the costlier operations by cheaper operations. That is why we go for this strength reduction kind of simplification. Yes, as said, we can use these kind of machine idioms wherever required, and which will probably reduce the cost of the entire set of assembly code, so that it can be the well optimized code. So to conclude, there are various number of intermediate code optimizations available already, but there is the need for optimizing the target code as well, which directly involves register allocation and memory allocation. And this Peephole optimization help the programmers and the compiler designers to well optimize the target code, so that the final assembly code is optimized in terms of space as well as in terms of memory. Use of machine idioms, removing the unreachable code or dead code, removing the redundant codes, redundant load and store, avoiding the unnecessary jumps. These are all the possible ways of improving the assembly code or applying the optimization techniques. So it is well understood that the principal sources of optimization help to optimize the intermediate code, and whereas the Peephole optimization can be well applied to the assembly code of the target final language. So end language, which can be applied to any target machine as well. That is the power of this Peephole optimization. This especially this machine idiom depends on the specific microprocessor architecture and set of instruction that the processor has. So hope this video finds you well and helps you on the optimization techniques that can be well applied on the target code. Thank you for watching this video. Bye bye.